Welcome to Beginner's Guide C Programming Tutorial Video Series. In today's session, we are going to discuss about memory management techniques in computer. Especially when we declare a variable, I'm sure that we know what is variable. Variable is a named location in memory where a program can manipulate data. That is called variable. So that variable required some amount of memory to store the data. The amount of memory that required by the variable is, it can be depends on the data type. I'm sure that we know what is data type. Even in the previous session we have seen what is data type and what is the use of data types and how we can use the data types. If you don't have any idea about data types, kindly watch my previous tutorial videos. You can find the link in the description box. So that amount of memory required by the variable is depends on the data type. It can be depends on the compiler, it can be depends on the machine architecture that we use. In the typical modern day compiler, it allocates 4 bytes of memory for the integer data type. Let's say this is an integer data type. Let's say the variable name is a. When I say the value is 5. So in the modern day compilers, it allocates for this data type integer 4 bytes. I'm sure that we know what is byte and how to calculate the bytes. 8 bit is equals to 1 byte. So for you to store this integer data type, this same statement required 4 bytes of memory. Like for example, let's consider this is a memory which is nothing but main memory which is nothing but the RAM that you use them in your computer. Let's say this is a memory, right? This memory will be divided into several parts. Let's say this is a memory. In this memory, each of this section is 1 byte. So what is 1 byte? 8 bits is equals to 8 bit is equals to 1 byte. For example, let's say this is a memory. This is a memory. Then in this memory will be divided into sections. Each section is 1 byte of memory. For example, in this memory, each block is going to have the memory address. Let's consider the memory address of this first thing is 0, 1, the second 2, 3, 4, 5, going up. If you want to store this integer data type, it requires how many bytes of memory? 4 bytes, isn't it so? So meaning it's going to occupy the first, second, third and fourth, meaning that this integer data type is going to occupy this memory location. So this value 5 will be stored into this position because this integer data is going to occupy these 4 bytes of memory. So among these 4 bytes, where are we going to store this data? Meaning that, okay, we know a computer, it can understand only the binary values, right? So it is not going to just store 5. This decimal number will be converted into the binary number. I'm sure that you know what is binary number. So what is a binary number for 5? You can say 0, 1, 0, 1. This is the binary number for 5. Let's say this is a 32-bit compiler. When it comes to the 32-bit, what does it mean? 32-bit means 1, 2, 3, So this is 8-bit, this is 8-bit, and this one is also 8-bit, this one is also 8-bit. So totally 32-bit compiler. So if you want to, so let's say this is a 32-bit compiler, this is a memory address, this is a memory, this memory has got an address, this address just assume that starting from 0 going upwards. So if you want to store this integer data, it requires 4 bytes of memory, meaning that what is the binary value for the 5001. So instead of these last 4 digits is going to be 0101. So this is the equivalent value for this decimal number 5. So where are we going to store this value? It can be stored into this first address. For example, this is 1 byte, isn't it? So 1 byte, which is nothing but it's equivalent to the 8 bits. So this 8 bits will be stored into this address, meaning that 0 0 0 0 0 1 0 1. So this value 5 will be stored into the memory address 0, or it can be stored into the memory address 1, or it can be stored into the memory address 2, or it can be stored into the memory address 3, because this integer is going to be occupied by 4 bytes. For you to store the integer, it occupies 4 bytes. These 4 bytes is starting from the memory address 0 up to 3. It can be anywhere. Maybe it can be in the memory address 200 or 201, 202, 203. As long as this is an integer data type, is going to occupy 4 bytes of data. That 4 byte of data is going to be stored into this memory location. Then computer has got the internal structure name called lookup table. So what does it mean, that lookup table? What it does, which has that lookup table has got the information about the variable and their location. Here what is the variable? A is the variable, meaning that A is the variable, the value is 5. So that lookup table is going to have the information about this variable. So what is that information? The information here is the variable A. The variable is A. It occupies the memory location starting from 0 up to 3. Because it's starting from 0 up to 3, this is 4. It's equivalent to 4 bytes, isn't it? So it's equivalent to 4 bytes. So this lookup table is going to have the information about this variable and the storage information. So this decimal value 5 will be converted into binary. Then that binary will be stored into this memory location. How can you find out that memory location? Using the lookup table. Lookup table is the one who is responsible to store the information about the variables. What is lookup table? Is the internal structure of the computer, which has got the information about the variable and the storage location. For example, here in this case, integer A is equal to 5. Again, in the same program, let's say you're declaring integer A is equal to 7. So what is going to happen? This 5 will be replaced with 7, meaning that this data is going to be removed from this memory location. Then again the corresponding binary value for 7. What is the corresponding binary value for 7? This is a binary value for 7. So this value will be stored into this memory address. It can be stored here, or it can be stored here, or here, or there. So for example, this is an integer A. If we have got integer again, another variable name called B. The value is 9. So what is going to happen? This first 4 bits is occupied by the integer A. Then the next 4 will be allocated to the variable name called B. So it's starting from 0 up to 7. That information will be stored into the lookup table. That lookup table has got the information about the variable B and the memory address. So this 9 will be converted into binary. Then you have to convert the binary number. That value will be stored into this memory address. So this is how the memory is allocated to the variable based on the data type it belongs to. I hope you understand the concept. For more tutorial videos, subscribe to Beginner's Guide.